Right, morning all. Thank you very much for joining us for this training session. So if anyone joined a bit late and missed the housekeeping, I'll just repeat that if you could add any questions to the chat function, and then we'll look at those at the end. But if there's any kind of burning issues for clarification, points of clarification, then enter them there and Richard can interrupt me. So my name is Richard Silverwood. I'm a statistician at CLS. So Alyssa's already given us a nice overview of the COVID-19 survey, and then following my presentation, we're going to hear in a bit more detail about two of the sections from the survey. And in between that, I'm going to speak a little bit about the response to the survey, about how we're defining our target population, and then looking in detail at one approach that we're proposing for dealing with non-response in the survey, and that's using inverse probability weighting using non-response weights. So, as I'm sure many of you are aware, non-response is common in longitudinal surveys. So that's a general statement, nothing specific to web surveys or to COVID-19, though of course these sort of factors will affect the level of response. When you have non-response, you have a reduced analytical sample, and therefore your analyses will be less efficient. So the symptoms of this are usually wider confidence intervals and larger p-values. But non-response can also introduce the potential for bias, since respondents will often be systematically different from non-respondents. So there are many well-known methods for dealing with non-response or missing data generally, including multiple imputation, inverse probability weighting that I'm going to discuss a bit more today, and full information maximum likelihood. So at CLS, we've been working to try to put out some guidance on how to robustly conduct analyses using our cohort data in the presence of non-response and other missing data. So for example, if you look on the website, you'll be able to find our user guide for handling missing data in NCDS, if that's of interest. So I'll look in a minute at the response levels in the different cohorts with regards to the COVID-19 survey. Spoiler alert, it's not 100% response, so there is some non-response to deal with. And so one approach that we're proposing, or other approaches, as I've said, are possible, is to use non-response weights. And these have already been derived and are provided within the data that are available from the UK Data Service. And so here you can use inverse probability weighting in your analyses to try and handle the non-response to the COVID-19 survey. And I'm going to discuss this in some more detail, but just to say briefly that in deriving these non-response weights, we've capitalized on the rich data that cohort members have provided over many years. And that's one real strength of the cohort studies, and we have this data over such a long period to utilize. So in this table here, we can see the response relative to the issued sample for each cohort in turn. So here I've jumped straight into the abbreviations, but if you saw Alyssa's presentation, hopefully these are already familiar to you if they weren't prior to today, so that we can see. And these are ordered, sorry, in year of birth. So NSHD being oldest, Millennium Cohort Study being the most recent. And here the last two rows that you'll see that we've split cohort members and parents separately in the Millennium Cohort Study. So we can see in the final column that the level of response relative to the issued sample is greatest in NSHD, being 68.3%, and generally decreases in the more recent cohorts. The total achieved sample that we had, which includes MCS parents, so just the sum of the response there, is 18,042, and that gives us an overall response rate relative to the issued sample of 35.7%. And if you exclude the MCS parents, and you'll see in a minute that some of the analyses that we're doing concentrate just on the cohort members within MCS, you get a response rate of 35.7%. And these levels are comparable to similar COVID-19 web surveys. So, for example, Understanding Society had a response of 38.7%. In conducting analyses using these data, it's important that we define a target population for each cohort, or certainly when we're thinking about developing non-response weights, we need to have a target population in mind so that when we're applying the weights that we've derived, we're trying to make the weighted results from the COVID-19 survey respondents representative of this target population. And so for the purpose of weighting, we consider the target population of each cohort to be defined as the individuals born in the specified birth period who were alive and still residing in the UK at the point of the COVID-19 survey. And so the vast majority of cohort members on whom we have data from the COVID-19 survey are within this target population, but the survey was also issued to a relatively small number of cohort members who had already emigrated from the UK. And for these individuals, we don't derive non-response weights, and indeed they're not included in the sample that we're using for deriving the non-response weights of other cohort members. And just an additional note on MCS, that we're only deriving non-response weights in cohort members, so not for their parents. And in MCS, the majority of cohort members are singletons, but there are also some twin pairs and triplet sets. And in these cases, we're only deriving weights for one of the twins and one of the triplets from each pair or set. Okay, so we're going to look a little bit more now at the derivation of the non-response weights. So this here is a slightly more technical bit for those who are interested. It's not essential that you understand all of this in detail in order to be able to conduct analyses yourself using the non-response weights, but it may be of interest and is certainly good background information. So in deriving the non-response weights, we did so separately in each cohort, but using a common approach set out here in 5 steps. So in the first step that I'm going to come back to over the next couple of slides in some more detail, we looked at the sample corresponding to the target population, and within this sample we modeled COVID-19 survey response, so that's just a binary variable for response versus non-response, conditional on a common set of covariates, here just using logistic regression. When we fit this model within each cohort, then for COVID-19 survey respondents, we predict the probability of response from the model. And so here, obviously, when we're looking to weight subsequent analyses using data from the COVID-19 survey, only those respondents to the survey will be able to participate, so we don't need to derive weights for anyone outside of that response pool. In step 3, we calculate non-response weight as the inverse of the probability of response. In step 4, we examine the distribution of weights across cohorts to decide whether truncation may be desirable. So here, when you derive the weights, it may be that there are some quite extreme outlying values. And when you use weights with such extreme outlying values, there can be issues, particularly with regards to the level of precision. So you may get quite wide confidence intervals. So what we did here is we just conducted some test analyses at different levels of truncation to see if we could truncate the weights in a way that would allow us to still reduce the bias due to the non-response, but in a way that minimizes any increase in the standard error or confidence interval width. And in the final step, we calibrate the weights so that they sum to the number of respondents within each cohort. Okay, so just looking in a little more detail at the response model in stage 1 of this process. So the response model here, we included a number of covariates that you'll see on the next slide listed out. The variables that we chose to include here are informed by the results of the CLS missing data strategy. So this is work that we've been doing over the last couple of years, thinking about how we can handle missing data within the CLS cohorts, and also informed by prior literature in this area. And also informed by assumed associations with the probability of response or with key COVID-19 survey variables. So because this process is being conducted separately within each cohort, we could have some flexibility over the covariates that we included in the response models, but we aim to use broadly the same set of variables in each cohort to ensure consistency. So obviously these cohorts are at different life stages and have been conducted, to some extent separately over the years. So it's not possible to include identical sets of variables in each model due to data being collected at different ages using different questions. And sometimes the variables that we would want to include just haven't been collected at all within a cohort. And there's further technical details in all of this in the user guide. So that's the COVID-19 survey user guide, which is available from UKDS alongside the data deposit. And sorry, just to emphasize that although we may not be including identical sets of variables in each of the response models, we don't consider that these minor differences to be likely to cause particular issues because the process is being conducted separately within each cohort. Okay, so this is just a list of the variables included within the response model, as I say, based on our own results in these cohorts and on the previous literature in terms of thinking about which variables might be predictive of non-response, and then also thinking about which variables are likely to be correlated with some of the important variables within the COVID-19 survey that are likely to themselves be subject to missingness. So the three columns here don't signify anything other than the fact that the list is too long to put into a single column. So you can see that there's a variety of variables across different sort of domains, and they may not be so apparent here, but across different parts of the life course. And if you're interested in exactly which of these variables are included for which cohort and at what age these data were observed, then again, all of that information is in the COVID-19 survey user guide. Okay, so having gone into a little bit of detail on stage 1, I'm now just going to whiz through stages 2 to 3 in this single slide. So as I said, from this response model, we predict the probability of response. We then take the inverse of this probability to calculate the non-response weight. We then conducted, as I said previously, a number of test analyses using different levels of truncation to the non-response weights. We found that truncating the weights at 50 still allowed us to remove the majority of bias, but to reduce the level of or maximize the level of precision relative to untruncated weights. So all of the weights within each cohort were truncated at 50. And then in step 5, we calibrated the weights, as I said previously. Okay, so we've now derived our non-response weights, but we want to know whether they actually work or not. So in order to do this, we ran a number of sort of test analyses to see whether or not the weights were effective in restoring sample representativeness. So, we could take variables that were observed as part of the COVID-19 survey. We could look at their distribution amongst the survey respondents without applying these non-response weights, perform the same analysis but applying the non-response weights and see how much impact the non-response weights have. But in that setting, there's no gold standard. We don't really know what the true estimate should be of a mean or a proportion, say. So one tool that we can use here is to do something similar, but instead using a variable that's collected earlier on. So usually at baseline in a cohort study, which will be observed in virtually all cohort members. So we did this for a number of different variables. If you have a look at the user guide, there's some more results presented there, but really I'm going to concentrate on sex here, which obviously we do observe in each cohort at baseline for virtually everybody. So we looked at the distribution of sex in 3 different ways. First of all, in all cohort members. So this allows us to look at what the true distribution should be within our cohort. We then looked at the distribution in COVID-19 survey respondents only. So that will allow us to assess unweighted analyses, which will allow us to assess the level of bias that may be induced due to non-response. And then in the third analysis, we're similarly looking at the COVID-19 survey respondents, but after applying the non-response weights. So comparing these results will allow us to see to what extent we're able to remove any bias caused by non-response. So a set of results here for sex. You'll see from the bottom that the grey bar represents that first analysis, so all cohort members. The red represents the analysis using COVID-19 survey respondents only, but unweighted, and the blue represents analysis using COVID-19 survey respondents only, but after the application of non-response weights. So results are presented separately for each cohort, and this is the percentage female. So looking first at NSHD, we can see from this first grey bar that about 50% of the cohort at baseline were female. If we look at this distribution within just the COVID-19 survey respondents, we see that there's some bias. So the non-response is not completely random. It looks like it's about 52% female, but it's not huge compared to some of the other surveys. If we apply our non-response weights, then the estimate that we get is much more closely aligned to the estimate using all of the survey in the grey bar. All of the cohort data in the grey bar. So in NSHD, there's not a huge amount of bias caused here when we compare the red and the grey bar, but we can see that in the more recent cohorts, there's a considerable amount. So we can see that, for example, in MCS, in the whole cohort, there's just under 50%, maybe 49% of the sample are female, yet 70% of the respondents to the COVID-19 survey were female. So in NCDS, BCS70 and MCS, we see that although this red bar is a long way from the grey bar, indicating pretty substantial bias, once we do apply our non-response weights in the blue bar, the levels are basically reduced to that of the grey bar, so that any bias induced by non-response, just in terms of the sex variable, has been essentially completely removed. This isn't quite true in next steps. We can see that the bias has been substantially reduced, maybe by about half, but it's not completely removed in this case. Anything else to note from this? I suppose that you may note that the confidence intervals signified by the length of the bar here for the red bars are always greater than the grey, but you would expect that because you're only analysing a subsample. So although in the previous slide, for next steps, the application of the non-response weights didn't seem to completely remove the bias with respect to sex. We have looked at this in a number of other variables, and we see that in other variables it does perform better in next steps. So this is looking at psychological distress score derived from GHQ-12, just mean GHQ-12 here, assessed at baseline in next steps, so in adolescence. We can see that we have a mean among all cohort members of about 1.7. This is increased among COVID-19 survey respondents to almost 2. But when we apply our non-response weights, we see that this is much more closely aligned to the value in the overall cohort members. So it seems that in these examples and other examples that we've looked at, the application of non-response weights does remove a lot and sometimes all of the bias that's induced by non-response to the COVID-19 survey. But this isn't a formal test for whether these weights are, universally appropriate. They're just kind of case studies. In these settings, it seems to work well, but that's not to say that it is always going to do so. Okay, so we've now derived the weights. We've seen that they work fairly well or very well in these settings. What if you want to apply them yourselves? So first of all, the non-response weights that we've derived here are provided as part of the COVID-19 survey dataset that's already available via UKDS. So in some of the cohorts, there are already design weights that need to be applied in any analyses that you do, or at least they should be. So that's the case in NSHD, Next Steps, and MCS. So because of the way that we're looking to apply these non-response weights in an inverse probability weighted approach, we can just combine those, take the product of those with the existing design weights to provide one overall combined weight to make available, and that's the weight that should be used in any analyses using the COVID-19 survey data. So that's what we've done in NSHD, Next Steps, and MCS. We've already combined our non-response weights with the design weights and produced this combined weight. So the variable name is CW1_comb weight. In the other two cohorts, so NCDS and BCS 70, there isn't the design weight that needs to be taken into account, but we've used the same variable name for consistency. In this case, it's simply the non-response weight. So how would you do this? How would you use these non-response weights in practice? So as I've just said, in NCDS and BCS 70, there's no study design to take into account, not even any design weights. So here we can just use the combined weight, the variable on the previous slide, to weight our analyses. In NSHD, there is a design weight to take into account, but as I've just said, this has already been combined with the COVID-19 survey non-response weight. So again, we can just use a straightforward weighted analysis for NSHD data. In Next Steps and MCS, life gets a little bit more complicated because as well as having a design weight, we've got primary sampling units, strata, and in the case of MCS, a finite population correction that should be specified in any analyses. And so for these cohorts, I'm assuming here that you're using Stata or the software available, you would SVY set the data and then use the SVY prefix for any subsequent analyses. So let's illustrate these analyses. So I'm going to show some code and output for each of the cohorts in turn. I'm going to illustrate it by estimating the proportion of individuals reporting having coronavirus in each cohort. So this is variable CW1 COVID-19, one of the first variables in the COVID-19 survey dataset. This is initially coded as 1, yes, confirmed by a positive test. 2, yes, based on strong personal suspicion. 3, unsure, and 4, no. So we first collapse the first two categories together and the last two categories together to form a binary variable. So it's coded 0 is no and 1 is yes. And then we'll have a look how we do these in Stata. But as I say, you may be using other software, but I would imagine that similar approaches are possible elsewhere. So NSHD, as I said, there is a design weight to take into account, but this has already been combined with the non-response weight. So here we can just p-weight using this combined weight. And sorry, I should say, I'm going to be using the same command throughout all of these. So that's proportion, which just gives us the proportion of this variable, which is the recoded binary variable coronavirus, yes or no. And here this if statement is just specifying CW1 cohort equals 6, is saying that it's NSHD. You'll see in subsequent slides that this is a different value for the other cohorts. And here it's not really the topic of this talk, but we're specifying as the confidence interval type the agresti-cool confidence interval, as you'll see in the output here. This is generally the preferred option in this type of estimation, although other confidence interval types are available. Okay, so here we just simply calculate the proportion, applying this p-weight, and we see that the proportion of NSHD cohort members with reporting at least having coronavirus, 2.1% with a confidence interval here. In NCDS, we said there's no design weight. So again, we just use this combined weight here. And here, in this case, this is just the non-response weight rather than being combined with the design weights. And now we see among NCDS cohort members, there's a reported prevalence of coronavirus of 5.8%. BCS 70, exactly the same. There's no design weight to take into account, so the combined weight is just the non-response weight. And we see here that the prevalence has gone up to 10.2%. In next steps, as I say, it gets a bit more interesting. So we are now SVY setting our data. We're specifying the PSU variable, and we're specifying the strata variable. So if you're familiar with analyzing these data sets, then you should see that the variable names we're using here are exactly the same as those that you would normally be using, but just with a CW1 prefix at the start to say that, to specify that they're within the COVID-19 survey data set. But the variables take exactly the same values as elsewhere. So we first SVY set, and then when we issue our proportion command, we use our SVY prefix. And here, because we've already specified the p weight, we don't need to do that as part of the proportion command. And we see here that we get a prevalence of 10.8% in next steps. Similarly for NCS, MCS, there's PSU to specify, there is a strata to specify, but now there's also the finite population correction to specify. And here we get a proportion of, or a prevalence of 5.5%. So hopefully that, seeing some examples will illustrate the types of analysis that you can do and how you would go about doing that. That is all I have to say. So thank you very much, and do let me know if there's any questions.
You do have a question there, Richard.
Okay, thank you. Just seeing that now. Thanks, Richard. So just confirming that target population is based on living members, not a particular pass wave for each cohort. There's an and, but then nothing following the and. So yes, the target population is based on those who are still alive and living in the UK or Great Britain, as is the kind of original target population definition for some of these. For some of the cohorts. So yes, in the cases where we have good data on whether cohort members have died or whether they have emigrated from the UK, then these individuals are excluded from the target population prior to the derivation of the non-response weights. So in MCS and next steps, we don't have mortality data. And so we haven't been able to make those exclusions, or rather we haven't been able to not create the non-response weights for any such individuals. But because there's a younger cohorts, we wouldn't expect mortality rates to be high. So although there may be some kind of overestimation of the target population and therefore some underestimation of response, we don't think that it's going to make a huge difference to the results.
Richard, there is a second part to that question if you hit the see more button.
Sorry. That didn't pop up for me originally. Hence, I assume no reason to apply past non-response weighting, longitudinal weighting, optimal weighting. Yes. So in this case, because we are, I think, in a situation where if you are using variables from prior sweeps of data collection, then your overall sample, or if you're using a complete case analysis, is likely to be largely determined by response to the COVID-19 survey, because the levels of response are admittedly a bit lower there, and therefore it really is non-response to that that's going to be driving exactly who is included in your analysis, and therefore it should be sufficient to just apply the COVID-19 survey non-response weights in order to get back sample representativity. Yeah. Okay, hopefully that answers that question. Please let me know if not. If anyone wants any further points of clarification or any other questions come to light, then please just drop me an email and I can handle those. I can see there's another question. As there are several different weights to implement depending on cohort, does this mean we have to analyze each cohort separately? So hopefully you saw that the weights themselves are actually the same variable in each instance. So we have this combined weight. So for some cohorts where there's not a design weight, that combined weight is just equal to the non-response weight. In cohorts where there is a design weight, it's equal to a combination of the design weight and the non-response weight for the COVID-19 survey. So there's a single weight variable there. So, but the complication really comes in MCS and next steps, where there are other elements to the survey structure that need to be taken into account. So the sampling was done in a way that means that you really do need to take into account the primary sampling units, the strata, in order to be able to have valid inferences. So in those cases, then yes, I think it really, the most straightforward approach is certainly to conduct these analyses separately if you want to ensure that you're getting reliable results for each of the cohorts. If there's an interest in obtaining an overall estimate, then one approach would be to analyze the cohorts separately in this way to ensure that you've got valid estimates in each of them, and then use a meta-analysis approach, or potentially meta-regression, I suppose, in order to combine them to get an overall estimate, because then you know that the cohort-specific estimates that you're putting into your meta-analysis will be appropriate, and in particular have appropriate estimates of uncertainty attached to them. So that could be one option there.
Okay, thanks, Richard. I can't see any more questions at this time, but I know that you'll be available at the end along with Alyssa just for any final questions. So I think we'll move on to the next section.
Thank you.
Thank you.